As we're aware, nonmetals are found on the right-hand side of the periodic table. Nonmetals bond together in order to form a type of bond known as a covalent bond. Covalent bonds are a shared pair of electrons between atoms. In this video, we're going to have a look at drawing dot and cross diagrams for covalent compounds and elements. When drawing dot and cross diagrams for covalent bonds, we show atoms as spheres, and an overlap is shown where the covalent bond will occur. A pair of electrons is placed in this overlap depending on the substance. Let's start off by looking at hydrogen. So in hydrogen, we've got two hydrogen atoms, and we've got that overlap to show that they're going to have a covalent bond between them. Each atom has one electron. In order to get a complete outer shell, it will share a pair of electrons in the overlap. And so that means that now both atoms have two electrons in their first shell, so a full outer shell. There is a single covalent bond between the two hydrogen atoms. A single covalent bond occurs when one pair of electrons is shared between atoms. Let's now have a look at hydrogen chloride. So in hydrogen chloride, we've got chlorine with 7 electrons. Hydrogen with 1 electron in its outer shell. So again, we're going to share one pair of electrons in the overlap and count to see how many electrons we have in total. So chlorine now has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and hydrogen has 2. Let us now look at chlorine. So each atom of chlorine has 7 electrons in its outer shell. So we're going to share a pair of electrons in the overlap and count. We can see that each chlorine atom now has 8 electrons in its outer shell, and so we have a complete outer shell, and that is the dot and cross diagram for the chlorine molecule. Let us now have a look at a molecule of water. Oxygen has 6 electrons in its outer shell. Each hydrogen atom has 1. Let's place a pair of electrons in each overlap. So we can now see that oxygen has a complete outer shell, and so does hydrogen. In methane, carbon has 4 electrons in its outer shell, and each hydrogen atom has 1. So we're simply going to put a pair of electrons in each overlap and count to see how many electrons we have in total. And we can see that we have a complete outer shell for the carbon atom and for the hydrogen atoms too. Let us take a look at ammonia. So we have 5 electrons in the outer shell of nitrogen, and so now what we can do again, put a pair of electrons in each overlap and count to see how many electrons we have in total. So we can see nitrogen has a complete outer shell, 8 electrons, and each hydrogen atom has 2 electrons in its outer shell, and so it's complete. Let's look at an oxygen molecule now. So we can see that oxygen has 6 electrons in its outer shell. So as we've done with the previous molecules, let's put a pair of electrons in the overlap. So we can now see that we've got 1, 2, 3, 4, 5, 6, 7 electrons in total in the outer shell of oxygen, and so that is incomplete. So let's put another pair of electrons in the overlap. And we can now see we have a complete outer shell for each oxygen atom, 8 electrons. 2 pairs of electrons shared between atoms represents a double bond. Let's look at carbon dioxide. Carbon has 4 electrons in its outer shell, each oxygen atom has 6. We have those 2 overlaps, so let's now put a pair of electrons in each one. So we can clearly see that oxygen has 7 electrons in total, and so does not have a complete outer shell. And so I'm not going to bother to count carbon outer shell electrons. And so what we're going to do is put another pair of electrons in that overlap, one from carbon, one from oxygen. And so what we can see now is that each atom has a complete outer shell, and we have double bonds between the carbon and oxygen atoms. Let's now have a look at a molecule of nitrogen. We can see each atom has 5 electrons in its outer shell. Let's put a pair of electrons into each overlap and count to see how many electrons we have in total. So with a pair of electrons, we have 1, 2, 3, 4, 5, 6 electrons in the outer shell. So this is not sufficient. We need 8 electrons. So let's put another pair of electrons in. And we can see that with the 2 pairs of electrons, we've got 1, 2, 3, 4, 5, 6, 7 electrons in the outer shell of each nitrogen atom. Again, not sufficient. We need 8. So let's put another pair of electrons in, and we can see we now have 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outer shell of nitrogen. So that is now complete, and we have a complete outer shell. So you can see we've got 3 pairs of electrons. This represents something known as a triple bond. So there's a triple bond between the nitrogen atoms. Thank you so much for watching. I really appreciate it. Please like, comment and subscribe and share this video to get it to more pupils like yourselves. All the best and see you in my next video.